Hi everyone, it's Miss Costa here, and in this video I'm going to go through the AQA Advanced Materials relating to the higher tier paper 1, which is tomorrow. So if you've got that, then this is great for some last minute revision, and as always let me know if there's something you want explained in more detail. Good luck! So to begin with, we're going to start with algebra, so have a look at all the topics, and that's the order I'll be doing them in. Okay, so to begin with, we're going to look at the equation of a line. So the question is giving you the point -2,5 on line A and 2 points on the line B. And it's telling you that they are parallel. Now, what we need to know about parallel lines is they have the same gradient. Okay, so if two lines are parallel, they're always going to have the same gradient. They have the same steepness. So that's a really important thing that we need to know. So they have the same gradient. And we are told to work out the equation of line A. Now, every single straight line can be written in the form y equals mx plus c, where m represents the gradient of the line and c is the y-intercept. Okay, so using this, we can use the coordinates of line B to figure out what the gradient of the line must be. And because line B and line A are parallel, that must mean they have the same gradient. So how do we work out the gradient? Well, the gradient is a measure of the steepness in the line, and we work it out by figuring out the change in the y coordinates over the change in the x coordinates. So every point is always written as the x coordinate first, followed by the y coordinate. So the gradient of this line would be, the y coordinate is 5 and 0. So how do you get from 5 to 0? There's a difference of 5. And then the x coordinates are 7 and 5. So the difference between 7 and 5 is 2. Therefore, the gradient would be 5 over 2. So we know the gradient of the line is 5 over 2, which is 2.5. So we can write that as y equals 2.5x plus c. Now that's the case for line B and also for line A. They're parallel, so they have the same gradient. Now we know part of the equation, and what we can do next is substitute the coordinates of line A that we have been given into this equation. So every coordinate, remember, is written as x and then y. So we can use this, that's x, that would be y, and substitute it in. So y would be 5. When y is 5, x is 2. So 2.5 times by -2 plus c would give me that part of the equation. So let's simplify it. 5 is 2.5 times -2. So that would be -5 over 2. -5. And you're left with -5 plus c. So how can we figure out what c is? Add 5 to both sides of the equation. So c is 10. And therefore, you've got the equation of your line. You know that y equals the gradient, 2.5, x plus the y-intercept, which we've just figured out, is c. So the equation of line A is y equals 2.5x plus 10. And next we've got some linear equations. So remember, when you're being asked to solve something, all that means is work out what the value of that variable is. So the variable we've been given is x. So let's see what we can do. Well, first thing I could do is expand the brackets. Okay, so I've got x over 8, x plus 8 over 3 equals 2x plus 6. I've just expanded the brackets. Remember, when you're expanding, you multiply the term on the outside by each term on the inside. Then what could I do? Well, x plus 8 is being divided by 3. So remember, if you have your little flow diagram, just to remember what the order of operations are occurring in, you could do that, or you might know how to do that without needing to do a flow diagram. So you know that the first thing you need to do is multiply both sides by 3. So we've got x plus 8 equals 3 lots of 2x plus 6. Now, if you're multiplying two terms by the same thing, you can put it in brackets. or you could have multiplied it and expanded the brackets out, up to you. So let's expand them. X plus a equals 6x plus 18. And then what could we do? Subtract, take this x from one side to the other. So when you've got x on both sides of the equation, all you want to do is move the smallest one from its side to the other side. And remember to move anything from one side of the equation to the other, we do the inverse operation. So we'd be left with 8 equals 5x plus 18. We'd subtract 18 from both sides. So 8 take 18 is negative 10. So 5x equals negative 10. Therefore, x, if we divide both sides by 5, is negative 2. And that's your answer. Okay, so here we've got an identity. Now, all an identity means is that the expressions on both sides are equivalent to one another, just expressed in a different form. So, if I expanded the brackets and simplified, the left side of the equation would be equal to the right side of the equation. So let's have a go and see what we can do. We can expand this side of the equation. So we'd be left with 5ax plus 20 plus 8 is equivalent to 35x plus 2b. Okay, so therefore 5ax plus 28 must be equivalent to 35x plus 2b. Now, 35x over here must be the same as 5a because they hold the equivalent value. So 5a must be equivalent to 35. So therefore, if 5a equals 35, a must be 7. We divide both sides by 5. So I know that the value of a must be 7 because 5 times 7 is the same as 35. And I know that 28, therefore, must be equivalent to 2b. So 28 equals 2b. Therefore, b must be, divide both sides by 2, 14. So you've got the values of a is 7 and b is 14. So here's a slightly trickier identity question. What can we do? We know that both sides are equivalent to each other and we can manipulate things slightly. So what I'd want to do ideally whenever I have a fraction, especially if it's got algebra, is get rid of that, unfraction the fraction. So multiply both sides by the denominator. So if I multiply both sides by x plus 3, I'd end up with ax squared plus 10x plus c equals x plus 3, 2x plus 4. What I could do then is expand the brackets. So x times 2x would give me 2x squared plus 4x plus 6x plus 12. Simplify. So 2x squared plus 10x plus 12 must be equivalent to ax squared plus 10x plus c. Now you can see which parts must be equivalent to which. So a must be equivalent to the 2. So therefore a must be 2. And what about c? Well, c is over here. So therefore c is 12. And that's all you need to do for an identity. You just need to know that both sides are equal to each other and therefore figure out the missing variables. Okay, so in this question, we are being asked to show that two fractions add together to and rearranged to make a quadratic. So the most important thing that we need to remember about adding or subtracting fractions is that they need the same denominator. Now with algebraic fractions, it's generally going to be the two denominators multiplied by each other. That's the lowest common multiple. So our denominators are going to be x take 2, x take 3. And then let's think what I need to do to my fractions in order to achieve that denominator. So the first fraction has been multiplied by x take 3. And whatever I do to the denominator, I must do to the numerator to keep the fractions equivalent. So that would become 3 brackets x take 3 plus, what have I done to this fraction? Well, I've multiplied the denominator by x take 2. So I must multiply the numerator by x take 2 as well. Now, because they both have the same denominator, I can simply add the two fractions together. So let's expand it before we do that. So that will become 3x take 9 plus 2x take 4. Okay, now I could simplify that even further. So 3x plus 2x would give me 5x, and negative 9 take 4 is negative 13 over, and let's expand this quickly. So x times x is x squared, x take 3 is negative 3x, minus 2 times x is negative 2x, and minus 2 times minus 3 is positive 6. So that would be simply x squared take 5x plus 6. Now let's make it equal to 5 because that's what we've been told. And what could we do? Well, let's rearrange it by multiplying both sides by the denominator. So we'd be left with 5x take 13 equals 5x squared take 5x plus 6. If we expanded that, that would give me 5x take 13 equals 5x squared take 25x plus 30. And then all I need to do is just rearrange it slightly. So let's take 5x from both sides. That would give me negative 13 equals 5x squared take 30x plus 30, and let's add 13. So we're left with 5x squared take 30x plus 43 equals 0. Now that is actually supposed to say 43. Sorry. Okay, so simplification of indices. So I'm being asked to work out the value of 3 to the power of 16 divided by 3 to the power of 6 to the power of 3. Now, when things are in brackets, remember, what does that mean? It means 3 to the power of 6 multiplied by itself 3 times. So the quick way is to multiply the indices, or ensure that you have the understanding. 3 to the power of 6 cubed would be 3 to the power of 18. So I'm left with 3 to the power of 16 divided by 3 to the power of 18. What do I do when I am dividing indices? Well, just like when I am multiplying indices, I add the powers. When I am dividing indices, I subtract the powers. So that would be 3 to the power of 16 take 18 is negative 2. Now, when you've got something to a negative power, what that means is it's like the reciprocal. So you write it as 1 over itself. So 1 over 3 squared. If it was, let's say, I don't know, 15 to the power of minus 5, you'd write it as 1 over 15 to the power of 5. Okay, so a negative indicates that it's 1 over itself. And I'm being asked to work out the value, so I have to actually work this out. What is 3 squared? 9. So that would give me 1 over 9. And a slightly trickier one, but doing the same things nonetheless. So you've got a fraction. Whenever you have a fraction, you want to just get rid of it by multiplying both sides by the denominator. So multiply both sides by minus 3. So you'd be left with y brackets x plus 3 equals 4x take 1. Remember, the reason you do the inverse is because it cancels itself out. Now you've got this nice little equation. Let's expand the brackets. So yx plus 3y equals 4x take 1. Now this, what can I do? Well, I want to make x the subject, so that means I want all of my x's to be on one side. So let's take 4x from both sides. So yx plus 3y take 4x equals negative 1. I obviously want to move the 3y to the other side because that's getting in the way. So do the inverse. So yx take 4x equals minus 1 take 3y. Now this is where a lot of people come undone, but all you're doing is you've got two lots of x, two terms that have x in it. So all you need to do is factorize it, and then you've got x on itself. So x is common to both of these terms. So if I factorize it, I'd be left with x brackets y take 4 equals minus 1 take 3y, and then I can just divide both sides by y take 4. And that's all you need to do. Now, it's never really nice to leave something as a negative. So what we could do is multiply both sides both parts of your fraction by -1. So x would be 3y plus 1, or 1 plus 3y over 4 take y. And that's your final answer. Okay, so in this question I'm being asked to factorise this quadratic. Well, I'm being asked to solve it, but in order to solve it I need to factorise it. So once again I have got quadratic and it's got a 2x squared, so I might want to set myself up a grid like this just so that I can figure out what's going on. So I know that my numbers must multiply to make -12. So what could that be? Well, -2 times 6, -12 times 1, -3 times 4, or the reverse. So which would multiply together to make -5? Well, let's have a try. So the beauty of this method is that you can just draw them out, put them in pencil, rub them out. So let's have a think. 2 lots of something, well maybe I'm going to try this. So 2 times by 4, and actually I'm going to try -4 because it needs to become -5. So 2 times -4 is -8x, and 2 times x times 3 is 3x. -8x plus 3x gives you -5x, and obviously 3 times -4 is -12. So in your brackets you'd have 2x plus 3 and x take 4 equals 0. So we've done the factorising part. If you need help with factorising these, just watch a video on factorising. I'm just going to go this quite quickly because we've got a lot to go through. So when you've got your quadratic in this form, how can you solve it? Well, you have to rearrange it to make x the subject. So what could we do? Now, a lot of you might know that when you're solving a quadratic, you just make it equal to the inverse of what's in the brackets. But let me just show you why we do that. If we divide both sides by x take 4, what would we be left with? Well, 0 divided by anything is 0. So you're still left with 2x plus 3 equals 0. Then let's solve it. 2x would be -3 and x would be -3 over 2. So that's why we do the inverse of the bracket. So that's your first value. And then you do the same for the other bracket. So let's say that we've divided it by, let's say we have 2x plus 3, x take 4 equals 0. And we divide by this bracket. What are we left with? We're left with x take 4 equals 0. Therefore, x equals 4. Okay, so when you are solving a quadratic, first thing you do is factorise it, make it, it's already equal to 0, and then divide each bracket one by one. 0 divided by anything is 0, and that's why you can solve your equations. Okay, so changing the subject, it's all it means is rearranging it, moving things from one side to the other in order to get a different thing as its subject. So we want to make x the subject. So what could we do first? Well, I've got brackets, so it's always nice to just expand them out. So 2x times 3 is 6x. 3 times y is 3y equals 17 plus 8y. What can I do? Well, I could subtract 3y from both sides to move it. Remember, when moving anything from one side of the equation to the other, you have to do the inverse. So we're left with 6x is 17 plus 5y. And then all I need to do to make x the subject is divide both sides by 6. So x is 17 plus 5y over 6. Okay, so this kind of graph is what we would call an exponential graph. It just means that things don't grow in a linear state. They kind of like boom and go off. So we are showing the graph of y equals 3 to the power of x. And we need to figure out the coordinate of point y. Once again, I've just mistyped that. So that's the point y over here. So the point y we know lies on the y-axis. Therefore, the x coordinate over here is going to be 0. And now all we need to do is figure out what the y coordinate will be. Well, I know that x is 0 on this coordinate, so y must be 3 to the power of 0. And hopefully you know that anything to the power of 0 is 1, so y is 1. Now just quickly to demonstrate why things are to the power of 0, let's just have like, let's say 2 squared, 2 cubed, 2 to the power of 1, 2 to the power of 0. 2 cubed is 8, 2 squared is 4, 2 to the power of 1 is 2. What's happening each time? You're dividing by 2. So therefore, if we follow the pattern, what's 2 divided by 2? 1. Okay, so I know it seems counterintuitive, but 2 to the power 0, 3 to the power 0, 472 to the power of 0, anything to the power of 0. So x to the power of 0 is 1. That's a key thing that you hopefully know. But either way, the coordinate of point y would be 0, 1. So you use the fact that x is 0 over here, substitute that into here, and you find your y coordinate. Okay, so sketching a quadratic. The key things that you need to know about this is that to find the roots of a quadratic, so where the graph crosses the x-axis, all you need to do is factorise your expression. So we've got y equals x squared, take x, take 12. If we factorise that, what are the factors of negative 12? Maybe 3 and 4, or 2 and 6, but let's say 3 and 4. How could they combine to make negative 1? Well, positive 3 take away 4 gives me negative 1. And 3 times negative 4 gives me 12. So that must be my factorised version. Now, just like when we're solving an equation, we'd make that equal to 0 because along the x-axis here, the y coordinate at every point will be 0. So we say, solve it like we did in the equation before. So x would be negative 3 and x would be 4. So I could just plot that over here. 4 could be roughly there. Negative 3 here. I'll just write that there. And I found my roots. Now what I need to do is figure out where it would cross the y-axis. So when it crosses the y-axis, x, the value of x, the coordinate of x would be 0. So let's substitute that into it. So y equals 0 squared, take 0, take 12. That must mean that the graph crosses the y-axis at 0, negative 12. So that's the coordinates for that. So I'd write negative 12 here. And the turning point of my curve, that's going to be halfway between minus 3 and 4 because quadratic graphs always have a line of symmetry. So minus 3 to 4 is a difference of 7. Half of that is 3.5. So 4 take 3.5 is 0.5. So you know that the turning point of your graph would be when x is 0.5. So let's just quickly sketch that. And there we go. Sketching a graph does not mean work everything out. It just means find the roots, find the y-intercept, look at the turning point and sketch it. Okay, so in this question, we are told that Ellison leaves her house at 9 a.m, walks at a speed of 3 miles per hour for 90 minutes, rests at a coffee shop for an hour, continues her journey for 30 minutes at a speed of 4 miles per hour until she reaches her destination. And I'm being asked to show this on the distance time graph. So she leaves at 9 a.m, so I know she's going to leave at the beginning, and walks at a speed of 3 miles per hour for 90 minutes. So speed is distance over time. So how could I figure out how much distance she's walked? Because that's what the y-axis is. I would do speed 3 times by time, which is 1.5. You always write your time is as a fraction of an hour. So 3 times 1.5 gives you 4.5. So you know she's walked 4.5 kilometres in the first 90 minutes. So 90 minutes would take me to 10:30 over here. And I look for 4.5, which will be over here. Now, I don't know how to use a ruler on this program, but hopefully you have a ruler. So you would just draw a straight line going up to 4.5 kilometres. She then rests at the coffee shop for an hour. So 10:30 would take me to 11:30 for an hour. And when you are resting on a speed distance time graph, the line is always flat. Okay, so when you're not moving, it is a flat line because obviously your distance isn't changing. Then she continued her journey for 30 minutes at a speed of 4 miles per hour. So I know that would take me to 12 p.m. because 11:30 to 12 is 4 minutes. And actually, I don't even need to do any calculations because I just have to join the line up. And that is all you need to do for your speed distance time graph. Okay, so when we are drawing inequalities on a graph, it's pretty much exactly the same as if we were to draw them as straight lines. It's just there's a few little tweaks. So If your line is less than or greater than, i.e. it's not equal to, then you draw a dotted line. If it's less than or greater than or equal to, then the line is solid. Okay, so here, let's just draw these lines as though they were just normal straight lines. So we've got the line y equals 2, the line x equals 3, and the line 4y take 2x is less than 8. We'll deal with that in a second. So if I were to draw the line y equals 2, how do I draw that? Well, the line y equals 2 is where the y coordinate is always 2. So let's have a think. Over here, what are these coordinates? That's 4, 2, 3, 2, 2, 2, 1, 2, 0, 2. That's why the line y equals is always going to be a horizontal line. So the line y equals 2 is over here. For the same reason, the line x equals 3 would be this line over here. And now, what I didn't do is take into account that this is an inequality. So because it says the line is y is less than 2, I must make it a dotted line. So let me just delete that and turn it into a dotted line. So you've got your dotted line over here. And now we have to deal with this inequality over here. So first of all, when you're doing something like this, you're going to want to rearrange it in the form y equals mx plus c. So let's imagine it's a straight line. 4y take 2x equals 8. I'd add 2x to both sides. So 4y is 8 plus 2x, or 2x plus 8. And then I'd divide both sides by 4. So y would be 2 divided by 4 is a half, half x. 8 divided by 4 is 2, a half x plus 2. So then I need to just quickly plot that. So let's just pick some random coordinates. 1, 3, 5, 7. So when x is 1, half of 1 is 0.5 plus 2 is 2.5. Maybe I should have picked even numbers. Let's do that actually. So let's pick the even numbers because we're going to be halving them. So when x is 2, 4, 6. So when x is 0, y would be a half times 0, which is 0 plus 2, which is 2. When x is 2, y is a half times 2, which is 1, plus 2 is 3. When x is 4, y would be a half of x, so 2 plus 2, which is 4. And when x is 6, y would be 3 plus 2, which is 5. So let's plot that. We've got 0, 2, 2, 3, 4, 4, and 6, 5. Maybe let's do another one. So let's say, I don't know, 9. No, let's do 10. So when, where's it deleting? So when x is 10, y would be a half times 10 is 5, plus 2 is 7. So 10, 7. Okay, so there you've got your linear line. And once again, I need it to be a dotted line because it's the line is less than. So I am going to just redo that as a dotted line. Obviously you'll have rulers and it will look a lot neater. So I'm being asked to shade the region that satisfies all of these inequalities. Right, so the first one, y has to be less than 2. So this is your line, y equals 2. And it has to be less than this. So what the y value has to be less than this. So it needs to be everything underneath this line. X must be greater than or equal to 3. So this is your line, x equals 3. And it must be greater than. So the x values must be greater than or equal to 3. So everything in this direction here. And then finally, we've got the line y equals a half x. So y would be less than a half x plus 2. So this is the line y equals a half x plus 2. And it needs to be less than that. So therefore, everything that is below here. So it needs to be below this line here as well, and larger than this line. So the only things that it could possibly be would be over here. So that would be the region that satisfies all of those inequalities. It's less than this line, greater than that line, and less than this line. Okay, so here we've got a velocity time graph, and we're being asked to calculate an estimate for the acceleration of the car at 6 seconds. Now, whenever you have an velocity time graph, in order to work out the acceleration or deceleration, you need to draw yourself a tangent, okay? So we can't really work out the acceleration of a curve, so we draw ourselves a straight line and work out the gradient of that. So it tells us to work out the acceleration of the car at 6 seconds. So 6 seconds is over here. I'd draw myself a straight line, as straight as I possibly can, and then figure out the gradient of that. Now, this obviously isn't the most accurate straight line in the world, but let's just have a go. So we've got this over here. So let's see, what's the distance? We go from 40 to 34. So the distance in y is 40 to 34, which is 6. The distance in x, we go from 5 to 7 seconds, so 2. So therefore the gradient would be 6 over 2, which is 3. So an estimate for the acceleration of the car at 6 seconds would be 3 meters per second. And because it's a negative gradient, the car is decelerating, it would be -3. Okay, so here we've got an algebraic sequence. We are told that the term-to-term rule for the sequence is multiply by 2. So if I had my thing that I enter in, x, I'd multiply it by 2, and then I'd add 5. I am told that the fourth term is 8x plus 51, and I need to work out the second term. So I'm going in the reverse. I'm going to need to undo or do the inverse of what I've got. So my function that I come out with is 8x plus 51. So what do I need to do? Well, first step, to go to the inverse, I would subtract 5, and then I would divide by 2. So 8x plus 51, take 5, would become 8x plus 46, and then divide it by 2. So that would become 4x plus 23. So the third term is 4x plus 23. I need to go backwards again to work out the second term. So I've got 4x plus 23. Take 5 would give me 4x plus 18, and then divide by 2 would give me 2x plus 9. So therefore the second term would be 2x plus 9. And now moving on to the number topics. So have a look at these and see which ones apply for you. And to kick off our number topic, we're going to start with some decimal arithmetic. So when you're multiplying with decimals, it makes life a lot easier if you just think about it as multiplying whole numbers and then manipulating a little bit. So 1.6 times 3.65. If I wanted to turn these into whole numbers, I would multiply 1.6 by 10 to give me 16. And I'd multiply 3.65 by 100 to give me 365. Now I've got some nice whole numbers. What I can do is just multiply them. Now you can choose whichever method works best for you. I personally really like the lattice method, so I'm going to use that. So over here, what's 5 times 1? That's 0, 5. 5 times 6 is 3, 0, 30. 6 times 1 is 0, 6. 6 times 6 is 36. 3 times 1 is 0, 3, and 3 times 6 is 18. Now all I do is add along the diagonal, so that would give me 0. 5 plus 3 is 8, plus 6 is 14, and I carry the 1. 6 plus the 1 is 4, plus 8. 6 plus 3 is 9, plus 1 is 10, plus 8 is 18, and then 3 plus 1 plus 1 is 4, 5. So that would give me 365 times by 16 equals 5,840. What have I done though? I times it by 10 and 100 to get this number. So in total, that's the same as timesing by 1,000. So return it back into decimal form, I would have to divide my calculation by 1,000. So what would that give me? 5.840. Now a little trick, the cheat way, is if you just count how many digits are after your decimal point, so 1, 2, 3, and your answer must have 1, 2, 3 digits after the decimal point as well. So turn them into whole numbers and then count the decimal points if you want to cheat, or just think about what you've multiplied it by and divide by the same if you want to do it properly. Now, dividing with decimals, we can also use a little trick here. So just to demonstrate why and how this works, let's think about something like, let's say 10 divided by 2. So 10 divided by 2, you know, is 5. If I multiplied both the 10 and the 2 by 10, I would get 100 divided by 20. Now what's that? How many 20s go into 100? 5. If I tried it again, so let's say 1,000 divided by 200, that's also 5. So hopefully you can see that when you're dividing decimals, as long as you keep, you multiply both of your numbers by the same power of 10, your answer is always going to be the same. So if I had, let's say 1 divided by 0.2, that would also be 5. So when you've got decimals, just turn them into whole numbers and your answer will be the same. So 6.4 divided by 0.4, if I times both of these by 10, I'd get 64 divided by 4. Remember, you have to multiply both of them by the same power of 10. And then 64 divided by 4, how many 4s go into 6? 1, remainder 2. How many 4s go into 24? 6. So therefore, 64 divided by 4 is 16, and 6.4 divided by 0.4 must also be 16. So answer for the first question, answer for the second question. Okay, so in this question, we are being asked to write 350 millimeters as a fraction of 0.2 kilometers and to give it in its simplest form. Now, what you need to notice is that you've been given two types of units. You've been given millimeters and kilometers. So the first step is to convert either both values to millimeters or kilometers. Now, we know that 1 kilometer is equivalent to 1,000 meters. And we know that in 1 meter, there are 100 centimeters. So therefore, 1 kilometer must be 1,000 times by 100, which would be 100,000 centimeters. What else do we know? We know that in 1 centimeter, there are 10 millimeters. So we're going to have to, so we multiplied 1,000 by 100 to get it into centimeters, and now we're going to multiply the centimeters by 10, because in 1 centimeter there are 10 millimeters. So therefore in 1 kilometer there are 1,000,000 millimeters. Now we have been asked to convert 0.2 kilometers into millimeters. So what do? We multiply by 1,000,000. So that would give me 200,000 millimeters. So I want to write 350 millimeters over 200,000 and simplify it. Now 35 I could divide by 10, 350 divided by 10, and 200,000 I could divide by 10. So I'd be left with 35 over 20,000. Now what else could I do? Well, I could divide both by 5. So 35 divided by 5 would give me 7, and 20,000, just in case you needed help with that. 75 is going to 2, 0. How many 5 is going to 20? 4, and then you know you've got your zeros there. So that would be 7 over 4,000. Now, does 7 go into 4,000? How many 7s go into 4? 0. How many 7s go into 40? 5, remainder 5. How many 7s go into 50? 7, remainder 1. How many 7s go into 10? 1, and you know it's not going to be a whole number. So therefore 7 over 4,000 is this in its simplest form. Okay, so in this question, I am being asked to work out which year has the greater proportion. So I'm told there are 300 students in year 7, 160 of which are boys, and there are 320 students in year 8, 180 of which are boys. So to find which has the greater proportion, I need to be able to put them into a comparable form. So let's write them as fractions. So year 7 is 160 over 300, and year 8 is 180 over 320. So let's start by simplifying these fractions. Well, let's just divide by 10, 16 over 30, and these ones would be 18 over 32. Let's simplify it further. Let's half it, so that would be 8 over 15, and over here that would be 9 over 16. Now, I can't compare these unless they are in the same denominator, so I need to figure out what the lowest common multiple of 15 and 16 is, and in this case it might just be easier to multiply 15 by 16. So 5 times 1 is 0, 5, 5 times 6 is 30, 1 times 1 is 0, 1, 1 times 6 is 0, 6. You've got 0, 3 plus 5 is 8, plus 6 is 14, and 1 plus 1 is 2. So the lowest common multiple of 15 and 16 is 240. What have you multiplied 15 by to get to 240? You've multiplied it by 16. So we want to do 8 times by 16 as well, and we'll just do this one like this. So 8 times by 6 gives me 48. 8 times 1 is 8, plus the 4 is 12. So that's 128 over 240. And then what have I done to 16 to turn it into 240? I've multiplied it by 15. So I'm going to need to do 15 times by 9. So 9 times 5, 45. 9 times 1 is 9, plus the 4 is 135. So therefore, now I have them in a comparable form, I can say that year 8 has the greater proportion of boys, because out of 240 students, 135 would be boys, whereas in year 7 only 128 would be boys. So to figure out proportion, put it into something you can compare. Okay, so when we're dealing with fractions, it's really helpful sometimes to just draw out a diagram so that we can see what's happening. So 4/5 of a number, I'm told, is 70, and I need to work out what that number is. Now, a common mistake people might make is work out what 4/5 of 70 is, which isn't what the question is asking. So it helps to draw out a visual diagram. So 4/5 means something has been split into 5 parts, and you are talking about 4 of those. So 4 out of 5 parts, that's what 4/5 means. Now 4/5 of a number is 70, so these 4 parts make up 70, and I need to work out what the original number is. So 70 is split into 4 parts, so how many 4s fit into 70? Well, 4s into 7 go once, remainder 3. How many 4s go into 32? 4 times 7 is 28, remainder 2. So I put my decimal point. How many 4s go into 20? 5. So I know that each part is worth 17.5. So if each part is worth 17.5, how could I work out the whole number? Well, I know this adds up to 70, and I've got another one part of 17.5, so the number must be 87.5. Value as a fraction of something else. So over here I want to write 34 as a fraction of 8. So I'm going to write that as 34 over 8. Now what I want to do is simplify that. So let's start by dividing both sides by 2. So that would give me 17 over 4. And that's it. That's all I have to do. 17 over 4. I can't simplify that any further. And that's that. Okay, so we're here in this question, I'm being asked to convert a recurring decimal into a fraction. So I start by saying that x is my original value, so 0.182 recurring. And what I want to do is get it so that I can write this decimal as something that can be subtracted from itself so that I get 0. So that might not make a lot of sense, so let's see what we do first. So let's say I multiplied this by 10. 10x would give me 1.82 recurring. So I'd get 1.82, 82, 82, 82, so forth, so forth. Now what I want to do is get it into the position where I've multiplied it by a power of 10, and the bit after the decimal point is also 8282. If I tried 100x, that wouldn't quite work, because that times by 100 would give me 18.2828, so forth, so forth. So if I subtracted those two, I would not get 0, so that's not going to help me. So I'm going to try 1000x. So it would give me 182.8282 recurring. So there I see that I've got the same digits after the decimal point in the same order. So now I can do something with that. So I've got 1000x, which equals 182.82 recurring. And I've got myself 10x, which is 1.82 recurring. So what I can do is subtract those. So 1000x take away 10x leaves me with 990x, and 182.82 recurring take away this gives me 181. And the reason I've done this is because 0.82 recurring take away 0.82 recurring cancels out. So I'm just left with x must be 181 over 990. Now it says write this as a fraction in its lowest terms. So 181, let's see what I can divide that by. And 181 I think is actually probably a prime number, but let's just try. So divide it by 2 I cannot do. Divide it by 3. How many 3s go into 181? 3s into 18 go 6. 3s into 1 go 0, remainder 1. So it's not 3. Can't be 5. Let's try 7. 7's into 181. 7's into 18 go twice, remainder 4. 7's into 41. Well, that's not going to be a whole number either. Let's try 9. So 108, well, that would be 2. And that would be 0, so it cannot be 9. And then the only thing left, I think, I guess, would be 11, which wouldn't go. So that, as a fraction in its simplest forms, would simply be 181 over 990. Normally, it would be a fraction that simplifies, but for some reason, this one doesn't. So a similar question, but here I'm being asked to prove algebraically that 0.36 can be written as 4/11ths. So what I have to do once again is start with my value being called x. So x is 0.36 recurring. If x was 0.36 recurring, 10x would be 3.636 recurring. And 100x would be 36.36 recurring. So I want to identify the ones that have the same digits in the same order after the decimal point, which is 100x and x. So therefore, 100x is 36.36 and x is 0.36. So what I want to do is subtract them. 100x take x would give me 99x, and 36.36 take 0.36 would give me 36. Therefore, x would be 36 over 99. If 99x, I divide both sides by 99. Now, I need to prove that it could be written as 4/11ths. All that means is I need to simplify it. So let's divide it by 2. Nope, don't want to do that because it's 99. Let's divide it by 9. So 36 divided by 9 is 4. 99 divided by 9 is 11. And there, you've proved it. 0.36 can be written as 4/11ths. Okay, so in this question, I am being asked about multipliers. Now it says, what multiplier is used to calculate a percentage decrease of 4.8%? Now, when I'm working with multipliers, what I always start with is 100%. Okay, so my original value is 100%, and I'm decreasing it by 4.8%. So if I started with 100% and I took away 4.8%, what would I be left with? 95.2%. Now, how do I turn a percentage into a decimal? And a multiplier is just the decimal form of the percentage. Well, percent means out of 100. So 95.2 out of 100. So 95.2 divided by 100 would be 0.952. So the percentage decrease of 4.8% would be 0.952 as a multiplier. Now for the next question, I have to do repeated percentage change. So it tells me the value x is increased by 10%. So remember, you start with 100% and you're adding 10%. So you've got 110% in total. 110 over 100 would give you 1.1 or 1.10. So x times by 1.1 gives you y. The value y is then increased by 30%. So once again, 100% plus 30% would give you 130%. So the percentage multiplier, 130 over 100 would give you 1.3. So you've got your y, which is x times 1.1, and that is then being increased by 1.3. So you multiply that by 1.3, and that gives you z. So you need to write down the multiplier used to calculate the overall increase. So what we want to do is 1.1 times 1.3. And how can I do that? Well, I could just do 11 times by 13. So 1 times 1 is 0, 1. 1 times 3 is 0, 3. 1 times 1 is 0, 1. 1 times 3 is 0, 3. So I'm left with 3. 1 plus 3 is 4, 1. So 11 times 13 is 143, but I want to work out 1.1 times 1.3. So you count the digits after the decimal, there's 2. So your answer is also going to have 2 digits after the decimal point. So 1.1 times 1.3 is 1.43. Therefore, the percentage multiplier to calculate the overall increase is 1.43. There's a total increase of 43%. Okay, so hopefully you remember that anything to the power of 0 is 1. If not, go back on the video and we went through why that is. Now over here we've got 4 to the power of 8 times 4 to the power of negative 3. When we're multiplying indices, so a to the power of x times by a to the power of y, all we do is add the indices together. So in this case we'd say 4 to the power of 8 plus negative 3. So that gives me 4 to the power of 5 over 4 to the power of 2. I've just simplified the top. 4 to the power of 5 over 4 to the power of 2. Well, when I'm dividing indices, so a to the x divided by a to the y, I just subtract the powers. So 5 take 2 gives me 3. So the value of n is simply 3. Now over here I've got a little bit of a trickier one. So I know that 3 to the power of y times by 3 to the power of 3y is 16. Now what do? The laws of indices state that when you are multiplying indices, you add the powers. So therefore I know that 3 to the power of y plus 3y must give me 3 to the power of 16. So I can extract that as a little algebraic expression. So y plus 3y must be 16. Therefore 4y is 16. Therefore divide both sides by 4. Y is 4. So if y has a value of 4, 3y would be 3 times 4, which is 12. So 3 to the power of 12 is what I need to do. Now it says work out the value of 3y, so I would have to do 3 to the power of 12, but I think I just miswrote that question. So I think it just meant work out the value of the 3y in that, and the value of the 3y would be 12. If not, you could do 3 times 3 multiplied by itself 12 times, but that is not what the question should be asking. Okay, so a quick little recap on fractional indices. Now, when you've got a fractional indice, all it means is the base power over here, that tells you what is to the root of, and the numerator tells you what it's to the power of. So in this case, it would be the cubed root of 8 to the power of 2. So what's the cubed root of 8? Well, that would be 2. So I'd be left with 2 squared. And what's 2 squared? 4. And that's all I need to do. Now it gets a little bit trickier over here with negative indices. So when you see a little negative, all that means is it's the reciprocal. So that would be 1 over 8 to the power of 5 over 3. So once again, what is the base mean? It means the root. So that's the same as 1 over the cubed root of 8 to the power of 5. What's the cubed root of 8? We just said that was 2. So I'd be left with 1 over 2 to the power of 5. And 2 to the power of 5 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2 again, which is 32. That should say 2. So the value of 8 to the power of negative 5 over 3 is 1 over 32. So in standard form conversions, what am I doing? Well, I know I need to have my number as a value between 1 and 9.9 times 10 to the power of something. So I turn this into a value between 1 and 9.9. So that's 5.735. And it's being multiplied by 10 to the power of 1, 2, 3, 4, 5, 6. If you ever get stuck in the exam, just start by multiplying it. So like here, I'd start by multiplying it by 10. 5.735 times by 10 is 57.35. Then try doing it by 10 squared. That would give you 573.5. And keep going until you get to your right number. Over here, when you've got a negative, so times 10 to the power of minus 4, well, a negative, let's think about what's happening. So if I had 10 squared, that's 100, 10 to the power of 1, that's 10, 10 to the 0, that's 1. What happens when I go into my negatives? Well, the pattern tells me I'm dividing by 10 each time. So therefore, when I go into my negatives, that means 1 over 10, or you could write that as 0.1. So essentially, what that means is 8.3 times by 1 over 10 to the power of 4. What's 10 to the power of 4? Well, you know, 10 cubed is 1,000, so 10 to the power of 4 must be 10,000. How else could you write that? 1 over 10,000 is the same as 0.1231. So when you've got a negative 4, you can just do a little cheat method where you count how many zeros are before your number. So 1, 2, 3, 4, that's the same as 1 over 10,000. So 8.3 times by 0.00001 would give me 0.123. So I've got 1, 2, 3, 4 zeros, and then I write my number. So conversion and calculation with standard form. Over here, all I need to do is actually physically work it out. So 5.3 times 10 to the power 4, I've got 5. And then I count my numbers, 1, 2, 3, 4. Okay, if you wanted to do it the long way, then obviously just do 5.3 times 10, 10 squared, and so forth and so forth. Otherwise, the cheat way, the quick way, once you've done this enough times, is to count how many digits are after your first letter. So that'd be 53,000 plus 4, and then 1, 2, 3, 4, 5. So 417,000. So let's add those two together, 417,000 plus 53,000. What are you left with? 7 plus 3 is 10. 1 plus 5, 6, 7, 4. So altogether, that's 470,000. And you need to write your answer in standard form. So turn that into 4.7 times by 10 to the power of 1, 2, 3, 4, 5. And there you have it. Okay, so dealing with surds. Now, surds are nothing to be afraid of. When you deal with a surd, what you should just think of it as is just another algebraic term. So a surd is just a number that is put in a root. It's like normally if you'd had, I don't know, let's say the square root of 49, you could write that as 7. Square root of 48, however, is going to be an ugly decimal. So instead of writing the decimal, we just leave it as a surd, and you can treat it as an algebraic term. So over here, when we're expanding the brackets, all we want to do is multiply each part by each part like we normally would. Now, I would probably encourage you to draw a little grid for surd multiplication, just because it's quite common for them to get missed out, just because you're dealing with surds and it's a little bit trickier. So what would I do? I do 2 times 5, which is 10. 5 times root 4, which would give me 5 root 4. 2 times negative root 20, which would give me negative 2 root 20, and root 4 times by negative root 20. So what would that become? Well, 4 times 20 is 80, so that would give me negative root 80. So let's write that out. We've got 10 plus 5 root 4, take 2 root 20, take root 80. So let's see what we can simplify from here. Now, I know that root 4 is the same as 2. So that's the same as just saying 5 times by 2. So I've got 10 plus 5 times by 2. And then here I've got root 20. Now, to simplify a third, what you want to do all the time is think of the highest square number that fits into it. So root 20, the largest square number, and I don't know, just write the square numbers if you forget them. So 1, 4, 9, 16, 25, 36. So the largest of these numbers that fits into 20 would be 4. So I could write the square root of 20 is the same as the square root of 4 times the square root of 5. What is the square root of 4? 2. So that would become 2 root 5. So instead of saying root 20, I would say 2 times by 2 root 5. Because I've just said that, you know, just figured out the root 20 is 2 root 5. And then what about root 80? Well, let's have a go at that. So what's the largest square number that could fit into 80? Well, let's just try it with, I mean, it's 16, but if you didn't know that it was 16 and you just want to try it the easy way, let's try that. So I could split that into root 4 times by root 20, which would give me 2 times by root 20. And over here, I figured out that root 20 is 2 root 5. So that would give me 2 times by 2 root 5, which would give me 4 root 5. So the root 80 can be expressed as 4 root 5. So let's clean this up a little bit over here. And let's see what I can do. So 10 plus 5 times 2 is 10. Take 2 times 2 root 5 would be 4 root 5. Take 4 root 5. So 10 plus 10 is 20. And minus 4 root 5 minus 4 root 5 is minus 8 root 5. Remember, treat the third as a little piece of algebra when simplifying. So if you said minus 4a, take 4a, that would give you negative 8a. And the same here, you get negative 8 root 5. And that's your final answer. So 20, take 8 root 5. I'm just going to get rid of all. And now it's the geometry and measures topics. So here they are. Have a look at which ones apply to you. Okay, so over here I'm being asked to prove a condition of congruence. Now, when I'm talking about congruence, there are 3 main ways that I can prove that something is congruent. If, well, there's right angled hypotenuse inside, but obviously this isn't a right angle, so we'll ignore that. There's side, side, side. So if 3 sides are exactly the same, then a triangle is congruent. If we've got an angle, a side and an angle, a triangle is congruent. And if we've got side, angle, side, then a triangle is congruent, which means exactly the same shape and size. So when we are looking at whether we can prove these points are congruent, we want to be looking for this. So we're told that DEF is an isosceles triangle, which obviously means that side DE and side DF are going to be the same. So these 2 sides are the same. Now, X and Y are points on DE and EF such that DX equals FY. So if DX equals FY, then we know that these 2 sides are the same. So I know that DX equals FY, therefore I've got a side. Now, I don't know which of these states of congruence I'm looking for yet, but I know that there is one side that is equal in those triangles. And that is all the information that I'm given. So prove that triangles XFD and YDF are congruent. Okay, so I've got that one side. What could I prove next? Well, I know that both of the triangles share this side here. So this triangle here, obviously this is the side over there. And for this triangle here, that also shares this side here. So DF is common to both. So once again, that's another side. So that is satisfied and that is satisfied. So I'm clearly not going to be using angle, side, angle. What else could I do? Well, I could either try and prove the last side, or I could try and prove that there is an angle in common. Now, bearing in mind that this triangle is an isosceles triangle, I know that the two base angles are going to be equal. So that means that over here, this angle here for this triangle and this angle here for the other triangle are going to be equal. So I could say that angle YFD equals angle XDF. Angle XDF. So therefore, they share a common angle. And so what have I done? Well, I've shown that there is a common side, XD and YF. I have shown that they have another side in common and that the angle between these sides is also common. So therefore, this is congruent through side, angle, side. Okay, so common side, and an angle in between those two common sides. Okay, so a prism and its surface area. So just really quickly, because we don't cover volume, if you were to need to work out the volume of any prism, all you do is work out the area of the cross section, which is the part where, imagine if it was like a cake slice. So imagine whatever the shape is, it was a cake, and if you sliced it, that would be what the cross section is. So the regular shape that goes all the way through your 3D shape. So area of cross section times by length. That's how you'd work out the volume. And here, however, we are being asked to work out the surface area. So when we're working out the surface area, it always helps to just draw out the different types of faces that there are. So you know you've got the front face over here, which is going to be common to the back face over here. So what's the area of that? Well, 8 times 6. Oh, nearly caught me out there. So how do I work out the area of a triangle? It's the base. So area of a triangle is base times the perpendicular height divided by 2. So it's always the perpendicular height. So this would be 7 times 6 divided by 2. 7 times 6 is 42. And 42 divided by 2 is 21. So I know the area of these two shapes here is 21 centimeters squared. So I could say triangle plus triangle equals 42 centimeters squared. Then I might want to work out all of my other faces. So think what is common. So you've got a rectangular base at the bottom. So you have one rectangular base, which is 6 times 5. So that would be 6 times 5 is 30 centimeters squared. And then finally, you've got the two slanted areas of the shape. So this part here, and then also this part here like that. So these are two rectangles, and the area of them is 5 times by 8. So you can use the slant height here because that describes this. So 8 times by 5 would give you 40 centimeters squared, and you've got two lots of them. So you'd say that plus this is 40 centimeters squared. What's the total surface area? You just add all the values up. So 42 plus 40 plus 30 gives you 82 plus 30, which would give you 112 centimeters squared. Now be wary that it's centimeters squared because it's an area. Surface area is the area of all the little parts of the shape. Each face, the area of all of them added up, not cubed, because that's a volume where we're talking about 3 dimensions. Okay, so exact trigonometric values. Most of you will probably have been given a table like this and told to memorize it at this stage in the exam, bearing in mind this is the night before. Either memorize it or don't. So sine 30, what's the value of sine 30? Well, sine 30, I'd go along here, down here, the value of sine 30 is 1/2. Okay, so you can use this table to try and memorize it, but if you don't understand how to work it out, don't worry too much. This won't be worth a lot of marks. No point in getting stressed the night before. Okay, so sector of a circle. Here I am told that ABC is a sector with a radius 6 centimetres and an area of 6 pi. And I'm asked to work out the angle of ACB. So what's the formula for the area of a sector? Area of a sector. Well, the formula for the area of a circle is pi times radius squared. And the formula for the area of a sector is whatever the area of the circle is multiplied by the fraction of that circle. So what we say that is theta, which represents the angle, over 360. So I know the area of the sector, I'm told is 6 pi, must be pi r squared, and I'm told that the radius is 6 centimetres. So 6 times 6 is 36, so pi r squared would be 36 pi, and that 36 pi times by theta over 360 is 6 pi. So let's simplify that. 6 pi is the same as 36 pi theta over 360. And what could I do? I could multiply 360 by 6. So 360 times by 6, 6 times 0 is 0, 6 times 6 is 36, 6 times 3 is 18, 19, 20, 21, 2,160. So 2,160 pi, I've just multiplied both sides by 360, is equivalent to 36 pi theta. Now what could I do? Well, I could divide both sides by pi. So 2,160 is equivalent to 36 lots of theta. And then I could divide both sides by 36. So 2,160 divided by 36. Well, I know that 2,160 divided by 360 is 6. So 2,160 divided by 36 would be 60. So where can I write this? So theta must equal 60. And that is the theta is just a name for an angle. So angle ACB equals 60 degrees. Now I'm being asked to calculate the size of the shaded area. So let's get rid of all of this and have a go at working out the shaded area. So the shaded area, I would need to work out the area of the whole sector and then the area of the smaller sector and subtract that. So I know the area of the large sector is 6 pi. Now let's see if I can work out the area of the smaller sector. So area of a sector is pi times radius squared times by theta over 360. Well, I know that the radius of this smaller sector is 3. 3 squared is 9, so that would be 9 pi. I worked out already that this angle here is 60 degrees. So how could I simplify that? Well, area is 9 pi. 60 over 360 would simplify to 6 over 36, which would simplify to a sixth. So the area is 9 pi over 6. You could simplify that if you wanted to. 2 divide both by 3. 3 pi over 2. And there's your area of the smaller sector. So this part here has an area of 1.5 pi. The large area is 6 pi. So the shaded area is going to be 6 pi take 1.5 pi, which is 4.5 pi as our final answer. Okay, so vector geometry. Now the key things we need to remember about vectors is that we always have to follow the direction of the arrow. Well, we don't have to, but if we go in the opposite direction, then it's the negative vector. So LMNP is a trapezium. I know that line LM is M, LP is 3L, MN is a third of LP. Okay, so if I know that MN is a third of LP, then a third of 3L is just L. So I know that MN is just L. The pen's gone a bit big, so let's just make it smaller. What else do I know? I know that B is the midpoint of NP. Okay, so this is the midpoint of NP, which means it's exactly halfway through. So I could figure out what NP is. Now, how could I figure out what NP is? I need to always follow a predetermined route. So how do I get from N to P? Well, I could go along here. So that would be negative L because I'm changing the direction. Along here, which would be negative M because I'm going against the flow of the direction. And along here, which would be plus 3L. So let's simplify that. NP would be 3L take L is 2L take M. So to get from N to P, that is my route. And I know that NB is going to be half of NP. It's halfway there because it's the midpoint. So therefore NB would be a half of 2 is 1 and a half of 1 is half. So L take away half M. That's what the root NB is. And therefore also BP would be L take half M because it's the same. So I am asked to work out the vector AB. So how can I get, let's just get rid of this, from A to B? Well, I can either go along here or I could go along here. So what do I want to do? Let's just have a think. Which would be easier. So I know that A is the point such that LA to AP is 1 to 2. So I know that 3L is split in the ratio 1 part to 2 parts. So therefore LA must be a third of 3L, which is just L. So LA is just L, and AP must be 2L. So there's a few ways I could do this. I could either go along the route of AP plus PB, or I could go down the route of AL plus LM plus MN plus NB. Which way to go? Let's just go along this way. So A to P plus P to B would give me A to B. The route from A to B, I could go from A to P and P to B. I've already said that A to P is 2L. And P to B, well, I know that B to P is L take 2M. So P to B would be the reverse direction. So that would be a half M take L. So I've got a half M take L, which equals, so 2L take L is L plus a half M. So therefore vector AB is L plus a half M. Okay, so constructing regions. Over here I have a scale drawing of a garden. Karina wants to plant a tree at least 3 meters from her hammock, point H. You can tell that summer's coming. She wants the tree to be nearer to WS than WG, and she also wants it to be at least 2 meters from GF. Shade the region where she can plant the tree. Okay, so the first thing here is that we are being asked for it to be closer to one line than another line. Okay, so here we've got WS, here we've got WG, and it needs to be closer to WS. Now, a lot of people just always get this wrong in the exam because they don't know what this is actually asking, and they think, oh, well, maybe I'll just do something random. So instead, what this is kind of asking you to is, if you remember when you've been doing constructions and bisectors, that's what we need to do here. So I don't have a compass, but let's pretend that I did. Oh, I have a ruler though. I didn't know that. Okay, so anyway, let's pretend that I have a compass. I put my compass over here and I just draw an arc. So open your compass up and you just draw an arc over here. You do the same, keep the compass exactly the same distance, and you draw an arc over here. Now, once you've done that, what you do is you keep your compass open still. And from this point here, you open your compass and you draw an arc over here. You do the same from this point, and you should get something like looking like this, which is the point where they meet. So this point is exactly the same distance from this line here as it is from this line here. I'll take the magic away and just go back to normal now. So the reason you do this is because if you connect this line to your original starting point, then you will have bisected the distance. So everywhere on this line, like if I went from here, it's the same distance from here to there. From here, it's the same distance as here to there. So this line is the same distance from both of those points. So that's kind of called like your line bisector. Let's just get rid of all of this. So you've got your construction lines, and you know that it needs to be closer to WS. So it needs to be like on this side. It can't be over here. What else do we know? So let's just do that on here. So I would have, with my compass, done boom, 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 and got, oh, I had the ruler in there. Okay, let's move the ruler. Oh, I don't know how to use it. Okay, let's get rid of the ruler then. Okay, never mind. So you just draw your thing like that. So that tells you the points that are nearer to WS. Now we also want it to be at least 3 meters from her hammock. So you've got your hammock over here. Let's do it in a different color. You open your compass, you measure 3, oh, you should have been given a scale. So, I mean, for the purpose of this, let's just say 1 centimeter is 1 meter. So open it up to 3 centimeters and just draw a circle around it. Obviously, you don't need to do the circle around the outside. You can if you like, but that's outside the garden. So all it means is that the tree cannot be planted anywhere inside of here. It's a no-go area inside of here. Obviously, we don't want to shade that because you shade the region, but it can't be inside of there because it needs to be at least 3 meters from the hammock, and that's your hammock. Okay, and then the last thing is that she wants it to be at least 2 meters from GF. So GF is this line here. Open our compass, draw a line of 2 centimeters, open our compass again, draw a line of 2 centimeters, and then just join them up together. So you want to shade the region where she can plant the hammock. Well, it could be in this little part here or anywhere over here because that satisfies all of the criteria. This is 2 meters away from GF, so it could be anywhere in here. Obviously, it can't be inside this area here because it's a prized hammock. You don't want shade. Well, actually, some people might want shade, but Karina doesn't. So no shade for the hammock. And it needs to be closer to WS than WG. So that is how we'd do that. And now here are the ratio topics. So not many, but simplest form and proportion problems. Okay, so here we've got a combination of ratio and some circle theorems. Remember, just because things aren't mentioned in the advanced materials doesn't mean they're not going to come up. So here we are shown a cyclic quadrilateral. Now, what do we know about cyclic quadrilaterals? Well, hopefully you know that in a cyclic quadrilateral, so anything that is kind of like encompassed by a circle, you know that opposite angles sum to make 180 degrees. So we need to use that information. So opposite angles sum to 180 in a cyclic quadrilateral. So therefore we know that a plus 30 plus C must equal 180, and we know that A plus B must equal 180. Now, we know that the ratio of A to B is 1 to 3. So, the ratio of A to B is 1 to 3, and we also know that A plus B makes 180. So, therefore, we need to split 180 into the ratio 1 to 3. So, that's 1 part to 3 parts. So, in total, that's 4 parts. So, 180 divided by 4, 4 is into 18, go 4, remainder 20, remainder 2, so 4 is into 20, go 5. So each little part is 45 degrees. So therefore, angle A is 45 degrees, 45 degrees over here, and angle B is 45 times 3, which is 135 degrees. So, oh, there's thunder outside. Okay, so we figured that out. We know that A, we figured out, is 45 degrees. So 45 plus 30 is 75. So this angle here is going to be 75. And therefore, 180 takes 75 gives me 105 degrees. Therefore, C is 105 degrees. And yep, that's it. Okay, so here I am given a ratio, and you might think, oh, that looks like it's in its simplest form. But for something to be in its simplest form, it needs to be whole numbers, really. So you don't want to have decimals. So I'm told that the ratio of lambs to sheep in the Shropshire Hills in May is 6 to 1.2. Write this ratio in its simplest form. Okay, the first thing I want to do is turn everything into whole numbers. So 1.2, the easiest thing I can do is multiply that by 10. But to keep everything in proportion, I must multiply the other side by 10 as well. So 6 to 1.2 becomes 60 to 12. Okay, you've got whole numbers. Now that you've got whole numbers, you can start to simplify. So what's the common factor of 60 and 12? Well, I mean, I know that 12 is a factor, but if you wanted to do it step by step, you could divide by 2. So let's say 30 to 6, divide by 2 again. That would be 15 to 3. And then what's the common factor? 3. So we could divide by 3. So that would become 5 to 1. So the ratio 6 to 1.2 in its simplest form is 5 to 1. Remember, simplest form means you want it to be in whole numbers, not decimals. Okay, so here we've got inverse proportion, which is quite a tricky topic, but absolutely fine if you've practiced it a few times. So the force between two magnets, F, is inversely proportional to the square of the distance between them. So we could say that F is proportional to the inverse of the square of the distance between them. So x squared. Remember, the square of the distance means like x squared. If it was the square root, then you'd say the square root of the distance. So try not to get hung up on the terminology. So the force between two magnets is inversely proportional to the square of the distance between them. Now, I've written my statement of proportionality. I could write that as F equals K over X squared. Hopefully, if this is making no sense to you, then watch a video on inverse proportion. So I've got my formula. Now I need to work out an expression for F in terms of X. Well, I've done that. F is K over X squared. Work out the value of F when X is 7. So all I do is substitute the values that I know. Oh, actually, no, I haven't done the expression bit first. Sorry. So I've done an expression, but you've also been given some information. So you know that F is 5 when X is 4. So let's substitute that in. So 5 is K over X squared, 4 squared. So that must mean that K is 5 times 16. So that would be 80. So K is 80. So all I've done is I've substituted F is 5 and X is 4. So I figured out what K is. So therefore, the expression for F in terms of X would be F equals 80 over X squared. Okay, so you use the information you've been given to figure out what K is. Now, I know that the formula is f equals 80 over x squared. I need to figure out what the value of f is when x is 7. So let's substitute 7 into the equation. 80 divided by 7 squared, which is 49. This is a non-calculator paper, so you can just leave it as a fraction, 80 over 49. And work out the value of x when f is 30, sorry. So 30 equals 80 over x squared. So let's just move things around a little bit. Multiply both sides by x squared, just so that you can get rid of the fraction. So 30 x squared equals 80. Then what could you do? Divide by 30, so 80 over 30 would become 8 over 3, because you divide by 10, and then we need to square root it, so x is the square root of 8 over 3. If any of this isn't making sense, it's rearranging formulae that you want to revise. Otherwise it's just substituting, and the first part is just inverse proportion. And here we've got statistics. There's only one topic, which is cumulative frequencies, so hopefully you feel confident on that. Okay, so in this question we're being asked about some koala bears. So the table shows information about the weights of 80 koala bears. Now, as you can see, there is one value missing, so I'm assuming that we need to fill that value in. So we've got 12 koala bears that weigh between 0 and 3. I'm assuming kilograms, I should say. So this here should say weight in kilograms. And over here, this should say number of koalas. Okay, so we have this missing value. So 12 plus 10 gives me 22, and 22 plus 38 gives me 60. They've told us that there are 80 koala bears, so therefore this missing value here must be 20 to complete it, so that there's 80 koala bears in total. Now I'm being asked to draw a cumulative frequency graph, and they've given you a spare table. That spare table isn't there for decoration, it's there to be used. So you use it to work out your cumulative frequency, CF for short. So between 0 and 3 kilograms, you know that you have 12 koala bears that weigh that. Then your cumulative frequency is going to say how many are between 0 and 6. So that's the whole point of cumulative frequency. It's the whole total, the running total of everything so far. So 12 plus 10 is 22. So in total, there are 22 koala bears that weigh between 0 and 6. You continue it. So how many are between 0 and 9 kilograms? Well, there's another 38. So 22 plus 38 is 60. And for your final part, how many koala bears are in between 0 and 12? Well, there's 80 koala bears in total, therefore the last column is going to be 80. So now you've got your values, you need to plot your cumulative frequency. Now you always plot it against the largest value of the interval. So the first coordinate is going to be 3, 12, then followed by 6, 22, 9, 60, and 12, 80. So let's plot that. We've got 3, 12. Oh, this is really small on here, so it might not be too accurate. Then we've got 6, 22. Then we've got 9, 60, and 12, 80. So we've got our cumulative frequency. It starts from 0, and I just join it up. It should generally look like an S, like a smooth curve. Okay, so I've plotted it. Now I need to estimate the interquartile range for the weight of the koala bears. Now the interquartile range is the upper quartile take the lower quartile, and what that means is the upper quartiles is 3/4 of the way through the data, the lower quartile is 1/4 of the way through the data. So essentially you've got 80 koala bears, so 3/4 of that, well, let's start with 1/4 because 1/4 is easier. 1/4 of that, 1/4 of 80, 80 divided by 4 is 20. And therefore 3/4 of that would be 60. So what you do is you start at 20, which is 1/4 of the way through the data, and you go along a cumulative frequency axis. Okay, you always go along the y-axis. So let's go from 20 and go across your graph and down. So this isn't super accurate, but I'd say it's 2, 4, 6, 5.6. So the lower quartile is 5.6, and then the upper quartile is, so from 60, let's go across and down. Once again, I didn't do that too accurately, but that would be 9. So your interquartile range would be 9, take 5.6, which is 3.4. So the interquartile range is 3.4 kilograms. Oh, and that's supposed to say weight of koalas, not number of koalas. It's quite late. Okay, 3.4 kilograms is the interquartile range. So remember, it's the upper quartile, take away the lower quartile. Now I'm being asked to estimate the number of koalas that weigh more than 8 kilograms. So I go backwards this time. So I go to 8 kilograms along this scale up to the graph. And then I go, oh, managed to somehow delete that. That's not ideal. Okay, so go up to 8 and then across, and that's 40. So, wow, apparently 40 koalas weigh more than 80 kilograms. So half of them weigh more than 8 kilograms. And that's all you do to estimate. You go find your value, go up to the cumulative frequency and across. And last but not least, we've got probability topics. So Venn diagrams, tree diagrams, expected value and independent events. Okay, so here we've got a Venn diagram question, and I've spiced it up a little by incorporating some algebra into it. So we are told that the Venn diagram shows information about the types of instruments that students play. Over here we have the universal set, so that means in total everything in the Venn diagram must sum to 60. And P stands for the piano, V stands for violin. So we are told that a student is chosen at random. They can play the piano, so they would be in this part of the Venn diagram. Work out the probability that they can also play the violin. Okay, on the sum of it looks like quite a simple question, but it's actually quite nasty. So we are told that there are 60 students in total, and we know that each part of the Venn diagram must sum to make 60. So the first thing we need to do is set ourselves up a little equation. So we know that x take 8, so this part here, x take 8 plus x plus x brackets x take 7 plus all of this, which would sum to 18, must equal 60. Okay, so I've accounted for each part of my Venn diagram, and I know that it must make 60. So next step, I can simplify it. So I've got x plus x, which gives me 2x. Let's expand this first. So you've got x, 2x, take 8, plus x squared, take 7x, plus 18 equals 60. Okay, let's simplify it even further. 2x take 7x gives you minus 5x. So let's start with the x squared. X squared minus 5x minus 8 plus 18 is positive 10. And that must equal 60. Okay, so you've got your quadratic. Now, whenever you have a quadratic, you should know by now, hopefully, that you need to solve it. So make it equal to 0 and then factorize. So let's take 60 from both sides. You've got x squared, take 5x, take 50 equals 0. So let's factorize it. Well, 50. Numbers that multiply to make 50, 5 and 10. And how can I combine them to make negative 5? So 10 take 5. No, negative 10 plus 5. So x take 10, x plus 5 equals 0. So therefore x is 10 or x is negative 5. Now we're talking about a real life context, so you're not going to use a negative value. You can't have negative 5 people that play the violin and the piano. So x is 10. So I can substitute that in to work out all of my probabilities. So I know people that play the violin and piano is 10. People that play the violin is 10 take 8, which is 2. So in this section here, we've got 2, and here it's 10. So violin is 12 people in total, and piano must be, so 10 times by 10 take 7 is 3, so that's 30, plus 10 is 40. So in total, 40 people play the piano. Now this is important because it says a student is chosen at random, they can play the piano. So therefore your probability is going to be out of the amount of people who can play the piano, which is 40. Work out the probability that they can also play the violin. Well, that's your probability section in here. How many people can play the violin and the piano? 10. So your probability would be 10 out of 40, which you could simplify to make a quarter. So it is tricky, but only tricky because you have to factorize and solve your quadratic. Otherwise, it works exactly how any other Venn diagram would work, where your universal set tells you what is inside, and the cross section is what is for both. Okay, so here we are going to be constructing our own tree diagram. So I'm told that there are pink and turquoise marbles in a bag. Maya takes a marble at random from the bag. So pink and turquoise marbles in a bag. She takes at random a marble from the bag and does not replace it. Now this is really important because it means our probability and the amount of marbles in the bag lowers. The probability of picking a pink counter from the bag is 5/8. Construct a tree diagram. Okay, so I've got my tree diagram. I've got first ball that is picked, and then I'll have the second ball. Okay, so I'm doing a branch for the first ball. So let's say the first ball is pink. The second ball is pink. And then let's say turquoise, and I'll do it in according colour. So turquoise here, turquoise, and turquoise. Now, I'm told that the probability of picking a pink counter is 5/8. So over here, I'm going to put 5/8, and on the branches, so each branch, the probability of each branch must sum to 1. So therefore here, that probability must be 3/8. Now, if I've taken out a pink ball, then that must mean that there are 4 pink balls left out of a total of 7, because I've removed a ball. So there are only 7 marbles left in the bag. Now, if I took a pink ball and then took a turquoise ball, there'd still be 3 turquoise balls out of a total of 7. So let's do the same for the lower branch. So if I've taken a turquoise ball out, there are still going to be 5 pink marbles in there out of a total of 7, because you've taken the turquoise out. And by the same token, there would be 2 turquoise out of a total of 7 left if you'd already gone along this route and taken the turquoise ball. So here's my tree diagram constructed and completed. And now I need to work out the probability that Maya picks counters that are different colours. So what routes can I take? Let's choose a different colour for this. I could go pink and turquoise. So when I go along the branches, I multiply my probabilities. So to get a pink and a turquoise, that would be 5/8 times by 3/7, which is 15/56. What other route could I take? I could go turquoise and then pink. So turquoise and pink is 3/8 times by 5/7, which is 15/56. So therefore the total probability, remember when you're finding out the probability of something and something else happening, we multiply the probabilities. That's why we multiply along the branches. But if it's the probability of this or that happening, my probability gets larger, so I add them together. So to figure out whether it's that or that, I would add these fractions together, which gives me 30/56. So the probability that she picks counters that are different colours are 30/56. Okay, so expected value. Now, in a fruit bowl, I'm told that there are only papayas, kiwis, watermelons, and mangoes. Quite a tasty fruit bowl. Jada picks a fruit at random from the bowl, and here are some of the probabilities. So I know that the papaya has a probability of 0.4 and kiwi 0.2. The probability of taking a mango is 3 times the probability of taking a watermelon. Complete the table. Okay, so the most important thing I need to know about probability when I'm working with decimal form is that it must add to make 1. So 0.4 plus 0.2 gives me 0.6, which means these two values here must add to make 0.5. So watermelon and mango must add to make a probability of 0.4. Now the probability of taking a mango is 3 times the probability of taking a watermelon. So therefore, if watermelon was x, mango would be 3x, like 3 times the amount of what a watermelon is. So therefore, 4x must equal 0.4 and x is 0.1. So the probability of getting a watermelon would be 0.1 and mango would be 0.3. Sometimes you don't need to do the algebra. Some people are really good at intuitively knowing that you split it into 4, but if not, always set yourself up a little equation. Okay, there are 20 fruits in the fruit bowl altogether. Complete the table. Okay, so if there are 20 fruits, all I need to do is multiply what my probability is by the total number of fruits. Similarly, if I was estimating, like, let's say, I don't know, the probability of picking a fruit is this. Every day it changes. What's the probability of picking a watermelon out of 500 days? You just multiply it by 500. So your expected value is always the probability times by the number of trials, which means like the number of days or the number of fruits there are, so forth. So 0.1 times by 20, well, a tenth times by 20 is 20 divided by 10. So watermelons, there'd be 2 of them. And 0.3 times by 20, that's 3/10 times by 20. So 60 divided by 10 would be 6. Let's just double check. Do they all add up to 20? So 8 plus 2 is 10. 4 plus 6 is 10. Yep, they add up to 20. Okay, and the last question. Jada is choosing a mango, but all of the watermelon are taken out of the fruit bowl. So 2 fruits are removed. So therefore the fruit bowl has 18 fruits remaining. So my total probability would be out of 18. Work out the probability of Jada choosing a mango. Well, that's 6 out of 18. You could simplify that if you wanted to a third. And that's all. Okay, so the last question. So if you've made it this far, then a huge congratulations. And we're just going to wrap up with some independent events. So I am told that Dennis, Dylan, and Jack each take a penalty. Probability of Dennis scoring is 2/3, Dylan is 2/5, and Jack is 3/4. I want to work out the probability that all 3 boys score a penalty. So in probability, we've got the AND rule, which is that if the event of this and that is happening, we multiply the probabilities together. Okay, so the probability of Dennis, which is 2/3, and Dylan, which is 2/5, and Jack scoring, which is 3/4. All I need to do is multiply those fractions together. 2 times 2 is 4, times by 2 is 12. 5 times 4 is 20, times 3 is 60. So all 3 boys scoring would be 12 over 60. You could simplify that to 6 over 30, which would be a fifth, but you have no obligation to do so because it doesn't say in its simplest form. And that's it. So thanks for watching, everyone. If you found it helpful, then don't forget to like and subscribe and turn on your notifications so you don't miss anything important for the upcoming exams. Once again, good luck.